To determine whether a rational expression is undefined, we just have to look at the denominator and check and see if the denominator is 0 or when it becomes 0. So to figure out when this becomes 0, if we set 7x minus 28 equal to 0, just like we did in the last chapter, and we factor out the 7 and set each factor equal to 0, so x minus 4, because the 7 we do not have to check for because it doesn't have a variable, and we get x equals 4. So when x equals 4, this denominator becomes 0. So we want to find all numbers that make it undefined, and undefined is when this is 0, so x cannot be 4. It can be any other number, but it cannot be 4. If we look at this next problem, we want to look at the denominator once again, and so we're going to make our denominator equal to 0 and solve. So we're going to go through the same process with the last chapter. So I'm going to factor, and this happens to be x plus 5 and x minus 2 equals 0. And then I can set each factor equal to 0 and solve. So if I'm setting each factor equal to 0, I would subtract 5 for this, and I get negative 5, and I would get x equals 2. So these two numbers would make this denominator 0, and since they make it 0, those are the two numbers it cannot be. That would make it undefined. Simplifying rational expressions means factoring out what can be divided out. So if I factor my numerator, so 5 is my greatest common factor, and I get x plus 7. And on the bottom, I could factor that as 5 times 4x. And the reason why I picked 5 is because 5 happens to be the number I have up top. When you have common factors, they cancel out. What's left over is our simplified expression. Nothing else can cancel. We cannot cancel these x's that you see right here. These right here is because one is attached with the plus sign and the other one is not. So those cannot be canceled. So you must have either the entire plus or minus, or it's separate to be able to cancel, and that's why we factor. So let's look at our next simplifying expressions. And I'm going to factor out the greatest common factor, which is x squared, which leaves me x plus 1 on the numerator, and x plus 1 is already in the denominator, and that can't be factored. Notice, this is what I was just talking about earlier, this right here is the exact same thing that can now cancel out. So if I cancel them, because they're the same, x plus 1 and x plus 1, I'm left with x squared. And so there's my simplified answer. Just like my simplified answer up here, let me just rewrite it, is x plus 7 over 4x. So there's my simplified answer. Let's look at the last one. So I'm going to factor the numerator. So x plus 5, x plus 1 gives me 5 multiplied and 6 in the middle. And then on the bottom, that's the difference of squares. So x plus 5 and x minus 5. I always put in parentheses so I can tell what goes with what. And if you look, the x plus 5 and x plus 5 are identical, so they cancel out. What's left over is x plus 1 over x minus 5. And there's my simplified expression. So we're going to go through the process of seeing some other types. So simplifying rational expressions, I'm going to factor the numerator, which happens to be 2x plus 5, because this is a difference of squares, 2x minus 5. And then on the denominator, 3 is my common factor. And when I factor that, I get 5 minus 2x. Now, if you notice within the parentheses, they're exactly the same, except that they're opposite signs. I have a negative 2 here, but I have a positive 2 in both of these. And I have a positive 5 here, and I have a positive 5 and a negative 5. What I can do when they're complete opposites is change the sign of the outside factor and flip this around. So this is what it's going to look like. So I'll have 2x plus 5 on top and 2x minus 5 on the bottom. On top as well. But the bottom becomes with a negative 3. I can flip the 2x to the front and make it positive, and then I can make the 5 negative. So basically the signs switch for these two because I added the negative. Now when you look at this, I have a 2x minus 5 and a 2x minus 5. They're exactly the same. They cancel out, which then leaves me as 2x plus 5 on top and a negative 3 on the bottom, which is my simplified rational expression. Let's look at the next one. Same idea. If we look at the top, that's a difference of squares. So that's 3x plus 7 and 3x minus 7. In my denominator, I have a 4, which is my greatest common factor, which leaves me 7 minus 3x. Once again, if you look, this is the opposite of those. So all I'm going to do, and do it in blue here, is rewrite my denominator. There's my numerator. My denominator with a negative 4 on the outside. So that becomes a positive 3x minus 7. So I just changed the signs of each of these with a negative out here. Now I can see what's the same, which cancels out those two, which leaves me 3x plus 7 over negative 4. And there's my simplified version.